Electrostatics. Topic is electric field due to dipole. We'll find this is a dipole. A dipole consists of two charges equal and opposite, plus q charge and minus q charge, separated by a small separation. This is 2a. O is the center of the dipole. So first of all, let us see for axial position. Now what do we mean by axial position? So this is the axis of the dipole, and I will consider this point P, which is at certain distance, and let this distance be r from the center of the dipole. So we have to find what is the electric field at P due to this arrangement called electric dipole at a distance r from center of the dipole. So first of all, I will take what is the direction of dipole moment vector. So as we know, dipole moment vector P vector, its magnitude is equal to magnitude of one of the charges and the separation between these two charges of the dipole, which is equals to twice a, and its direction is from minus q to plus q. So we can show here that this is the direction of dipole moment vector. It is in the direction from negative to positive charge. Now let us consider, in order to find what is the electric field here, the electric field of plus q charge. Now this electric field due to plus q charge, I will write as electric field of plus q charge. This is equals to k q upon distance square. And what is the distance from this plus q charge to this point? So if I call this as a and if I call this as b, so I have to take this distance ap square. Now this is the magnitude of electric field, but it has some direction. So we know that it is positive charge. So positive charge will have the electric field directed away from it, and it is electric field due to plus q charge. Now we know that this is also the direction of this p vector. So here I will write the direction as p cap. Now what is this p cap? So it is unit vector along p vector. So both are having same direction, so this will give the direction of. Now we can write it as k q. What is ap? So this ap equals to r minus a whole square. So this distance is r. Subtracting this, you will get this distance, and it is p cap. Now similarly, I will write electric field due to the negative charge minus q. Now this is the negative charge. The distance is this. Distance is bp. So it is k q upon the distance. It is bp square. Now one thing is clear. I have written plus q because I am writing the magnitude, and here the direction will be, it is always the negative charge has an attractive field. So this is electric field due to minus q charge. Now I will write the direction as it is minus p cap, opposite to p vector. So minus p cap, it is unit vector opposite to p vector. Now when I write this, this is simply k q upon bp square. So what is bp square? So from the diagram you can clearly see that this is this r plus a. So this is r plus a whole square into minus p cap. This is the magnitude part, and this represents the direction. Now how we'll find what is the net electric field? So we know that net electric field E at the axial position, we know superposition principle tells us that the net electric field at any point is vector sum of these two electric fields. So if we know that this is closer charge which will have more effect than the charge which is farther, so I will take the direction of electric field in this direction. So here net electric field will be E plus Q plus E minus Q. Now when you are adding them vectorially, you will get this K Q term common, and this will be 1 plus R minus A whole square P cap minus 1 by R minus A whole square P cap. I am writing the direction with P cap, so when I finally solve this, what I will get is K Q. This P cap I can take out, and this will be taking the LCM R square minus A square whole square, and here it will be 1, this will be taking LCM, so this is the denominator, and it will be R minus A whole square minus R okay, R plus A whole square minus R minus A whole square with P cap. So here this term has R plus A, and this has R minus A, so we'll rectify this part here. So this is P cap. Now when I solve this, this is simply K Q A plus B whole square minus A minus B whole square. So if you simplify this mathematically, you will get 4AB. So here 4A, A is R and B is A, divided by this is R square minus A square whole square with P cap. Now we will make some simplifications here, and the first one is we have electric dipole moment which is Q into 2A. If you see here Q into 2A, and if you separate that part, what you will get, it is K, this is 2, so it will be 2QA will be P R, this is P cap divided by R square minus A square whole square. Now in this expression we know that what is K? K is 1 by 4 pi epsilon 0. So everywhere I am using this K, so I will write here K, it is 1 by 4 pi epsilon 0, which is 9 into 10 to the power 9. So here we are getting finally this is 2 K P R upon R square minus A square whole square. Now this P into P cap, it is the magnitude of dipole moment, it is direction of dipole moment. So you can put this as P vector. Now this is the electric field expression at axial position due to electric dipole